It takes 100 hours to build a single Porsche engine by hand. That's more than twice the time required for most luxury vehicles. And there's a critical reason why. In this exclusive look inside Porsche's most guarded production facility, we'll show you why this painstaking process matters, and how it creates machines that continue to dominate both racetracks and roads decades after leaving the factory. What if the secret to Porsche's legendary performance isn't in their machines, but in their people? In an era where automotive manufacturing increasingly embraces automation, Porsche stands as a notable exception. Walking through their production facility in Stuttgart, Germany, reveals something unexpected: human hands touching nearly every critical component. While competitors race to implement fully automated assembly lines, Porsche maintains a different philosophy. Thomas Meyer, a 24-year veteran engine technician at Porsche, explains, "We could automate more, but we choose not to. Some things machines simply cannot feel." This approach seems counterintuitive in today's efficiency-obsessed manufacturing world. Most luxury automakers promote their robotic precision as a selling point. Yet at Porsche, master technicians like Meyer work in specialized stations throughout the engine assembly area, where each component undergoes meticulous human inspection before installation. The careful choreography becomes evident as we follow Maria Schmidt, an engine assembly team leader with 16 years of experience. She demonstrates how technicians test the fit of each piston ring by hand, feeling for the precise tension that automated systems might miss. It takes a minimum of 4 years before any technician is permitted to build an engine unsupervised. Schmidt explains, "Some components have tolerances measured in microns, thinner than a human hair. Our fingers can detect irregularities that sensors sometimes miss." This training process includes 2 years of foundational mechanical training, followed by 2 years of specialized Porsche-specific techniques, all before a technician can work independently on production engines. Perhaps most surprising are the tools themselves. Unlike the standardized equipment found in most factories, Porsche maintains an in-house tool development team. Stefan Bauer, head of specialized tooling, shows us a custom-designed torque wrench used exclusively for Porsche crankshaft assembly. "This was developed specifically for our flat-six engine configuration," he explains. "You won't find this anywhere else in the world." These specialized tools, many with ergonomic handles shaped through hundreds of iterations based on technician feedback, represent a hidden advantage in Porsche's manufacturing approach. The quality control measures extend beyond specialized tools. Unlike many manufacturers who assign different workers to different engine components in assembly line fashion, Porsche employs what they call the single builder approach for their most prestigious power plants. One technician oversees the entire assembly process from beginning to end. When one person builds the entire engine, there's a psychological difference, explains Dr. Werner Hoffmann, Porsche's director of production quality. They take personal ownership of their work in a way that's impossible to replicate when responsibilities are fragmented. This personal accountability reaches its ultimate expression in a tradition that few outside the company know about. Each engine builder personally signs their work. On a small plate affixed to the completed engine block, the builder's signature creates a direct connection between craftsperson and customer. While many assume modern Porsches are primarily machine-made, several critical components remain entirely hand-assembled. The engines, particularly the iconic flat-six, the complex dual-clutch PDK transmissions, and the meticulously stitched leather interiors. These components directly impact either performance or the tactile experience of driving, areas where Porsche believes human hands make a measurable difference. "A machine can tighten a bolt to exact specifications," notes Franz Miller, a 30-year Porsche veteran. "But it cannot feel when something is slightly off in ways that don't register in numerical data." That's where human craftsmanship becomes irreplaceable. This human-centered manufacturing philosophy extends beyond just engines. In the leather workshop, we observe master upholsterers hand-stitching steering wheels, each requiring over 400 precise stitches. Rather than using automated cutting machines, leather panels for seats are hand-selected for optimal grain patterns and matching characteristics. Beyond the skilled hands that craft each vehicle lies a scientific battleground where materials fight for their place in a Porsche. In laboratories hidden from public tours, engineers subject potential components to punishments that would make most automotive materials fail within hours. These testing facilities, rarely seen by the public, form the foundation of Porsche's durability reputation. We're standing in what Porsche engineers call the torture chamber, a sealed testing room where materials face decades of simulated abuse. Dr. Claudia Weber, head of materials science at Porsche, gestures toward a rack of leather samples being bombarded with concentrated ultraviolet light. What you're witnessing is 30 years of solar exposure compressed into 3 weeks, Dr. Weber explains. Only materials that maintain structural integrity and color consistency through this process ever make it into production. The leather sample rotates slowly as automated sprayers periodically mist it with a solution that mimics acidic rain. In an adjacent chamber, dashboard components endure rapid temperature cycling, shifting from minor 40 degrees to 85 degrees Celsius every 30 minutes, a thermal shock that would cause standard plastics to crack within days. While industry standards typically require materials to withstand 500 such cycles, Porsche mandates 1,500 cycles before approval. The industry generally tests to consumer expectations, notes Dr. Weber. We test to extremes that most vehicles will never encounter, because a Porsche is expected to remain functional for decades, not years. This philosophy extends to Porsche's approach to metallurgy. In a restricted area requiring special clearance, we observe the development of proprietary aluminum-magnesium alloys used in critical structural components. These alloys provide 27% greater strength-to-weight ratios than industry-standard alternatives, while maintaining superior resistance to fatigue. Dr. Marcus Schaefer, senior metallurgist, demonstrates how Porsche tests these alloys by subjecting small samples to over 2 million stress cycles, simulating a lifetime of road vibrations. When other vehicles begin to develop stress fractures, our components remain structurally sound, he says while examining a test specimen under an electron microscope. Perhaps most impressive is Porsche's paint development laboratory. Here, chemists formulate coatings that must withstand not just environmental factors, but also the aerodynamic stresses of high-speed driving. Standard automotive clear coats typically contain 2 to 3 specialized polymers, but Porsche's proprietary formulation incorporates 7 different compounds, creating a matrix that distributes impact energy from stone chips across a wider area. At 270 kilometers per hour, a small stone impact has the force of a bullet, explains Dr. Heike Miller, head of Surface Technologies. Our coating systems must dissipate this energy while maintaining the aesthetic qualities customers expect. Following a body panel's journey reveals the exhaustive process behind each component. Selected aluminum sheets undergo electrical conductivity testing to verify precise alloy composition before forming. After shaping, each panel receives a proprietary treatment that creates microscopic pores in the surface, invisible to the naked eye, but critical for paint adhesion. The most dramatic demonstration occurs in the destructive testing facility. Here, finished components face mechanical stresses until failure. We watch as a suspension arm designed to support 2.5 times the vehicle's weight finally fractures under hydraulic pressure, but only after exceeding its design specification by 348%. This is where we learn the most, says Thomas Beck, head of structural testing. Understanding exactly how our materials fail allows us to engineer redundancies into critical systems. Beck's team collects precise data from each failure, feeding information back to design engineers who continually refine formulations and structural geometries. The payoff is revealed when Dr. Weber shares a startling statistic. Over 70% of all Porsche vehicles manufactured since 1981 remain roadworthy today. This longevity stems from testing standards that exceed industry norms by an average of 300% and proprietary material formulations that resist degradation far beyond typical automotive timeframes. Creating materials that last for decades is only half the equation. Assembling them correctly is where Porsche truly separates itself from competitors. In an era where automation dominates manufacturing, Porsche maintains production islands where robots are explicitly forbidden. A counterintuitive approach that somehow produces better results than the industry-standard assembly line that Henry Ford pioneered over a century ago. Walking through the Central Assembly Hall in Stuttgart, visitors immediately notice something unusual. Instead of a continuous line with cars moving at fixed intervals, vehicles progress through distinct zones at varying paces. Each zone functions as what Porsche calls a production island, a self-contained manufacturing cell dedicated to a specific assembly stage. Most automakers optimize for throughput above all else, explains Johanna Becker, Porsche's head of production strategy. We optimize for precision first, then efficiency. our modular approach allows us to maintain flow while giving each vehicle exactly the time it needs at each stage. This philosophy becomes particularly evident during the marriage, the moment when a vehicle's powertrain meets its chassis. Unlike conventional assembly, where this occurs at a predetermined point regardless of complexity, Porsche's system adapts to each specific build. A base model Cayman and a fully customized 911 Turbo require fundamentally different marriage procedures. Becker notes, "Our island system allows us to route each vehicle to specialized teams with expertise in that particular configuration. This flexible routing creates a visually chaotic-looking factory floor that somehow produces meticulously assembled vehicles. Cars appear to move sideways and backward at times, following non-linear paths determined by their specific build requirements." The most striking aspect of Porsche's assembly philosophy becomes apparent in certain production zones where robots are conspicuously absent. While competitor factories showcase advanced robotics, Porsche deliberately maintains human-centered assembly stations for critical components. Dr. Anton Miller, Director of Assembly Innovation, explains this counterintuitive choice. "We've actually removed robots from certain stations after finding they couldn't match human adaptability. When tightening suspension components, for example, an experienced technician can feel when something isn't aligned correctly in ways no machine can detect." This approach doesn't mean rejecting technology. Instead, Porsche deploys what they call human collaborative technology, tools that enhance human capabilities rather than replace them. We observe technicians using augmented reality glasses that project assembly instructions directly onto their field of vision, ensuring precise placement without requiring them to look away from their work. Following a Cayman GTS through quality checkpoints reveals another distinctive element of Porsche's approach: parallel rather than sequential inspection. Instead of a single end-of-line check, each vehicle undergoes constant evaluation throughout assembly. Traditional manufacturers inspect completed vehicles and address issues afterward, explains Quality Director Elena Wagner. "We verify at each stage, preventing defects from being built into the car in the first place. It's more labor-intensive, but eliminates the need for costly rework later." The most substantial departure from industry norms comes in how Porsche handles customization. While most manufacturers limit options to maintain efficiency, Porsche has designed their production flow specifically to accommodate extensive personalization. "Each vehicle enters our system with a complete digital twin," Wagner demonstrates, showing a tablet displaying a 3D model of the exact Cayman we're following. Every custom specification is mapped in advance, with assembly instructions generated automatically for that specific build. This approach enables Porsche to offer over 14 million possible configurations for a single model without disrupting production flow, a level of customization that would paralyze conventional assembly lines. Throughout our journey inside Porsche's manufacturing world, we've discovered something profound. The Porsche difference isn't about one secret ingredient, but a holistic philosophy. Their approach interweaves human expertise with technological innovation in perfect balance. We've witnessed how material selection forms the foundation, with proprietary formulations undergirding everything that follows. The human touch remains paramount where it matters most, with master craftspeople applying skills that machines simply cannot replicate. As the automotive industry races toward automation, Porsche stands as evidence that the irreplaceable human element, judgment, adaptability, and pride in craftsmanship, creates vehicles that transcend transportation to become enduring expressions of engineering excellence.